Hi, so I'm just going to fly through a quick explanation of this 2011 question, which is on the bleach titration. So I'm just flying through part E and part F because they are the calculation parts of the question. So if you can remember, in this bleach titration, we have two balanced chemical equations that were given. So the first one is this one here. This is sodium thiosulfate and iodine. And then you have your products. And the second equation we're given is this. This represents the bleach. This is called the hypochlorite ion. And I have this circled here because you can see that the thing they have in common, we have I2 in this balanced chemical equation. We also have it up here. So the purpose of this titration is to find out how much of this hypochlorite ion do we have in the bleach. So at the beginning of the question, we don't have enough information to try and work that out based off of this balanced chemical equation. So that's why we always start off with the thiosulfate equation. So in the question, we're told that we have a molarity of 0.1 and a volume of 16.1. And both of those are to do with this sodium thiosulfate. So the first thing I'm going to do here is using my molarity formula. I've worked out the number of moles of thiosulfate, which is 0.1 multiplied by the volume in litres, and that gives me 0.00161 moles of the thiosulfate. The second step here is to do with the ratio. So you can see I have 2 moles of thiosulfate for every 1 mole of iodine that I have. So in order to work out the moles of iodine, I've just divided this value by 2. So this means that I had 0.000805 moles of I2 in the conical flask, at the end of the titration. So I'm now able to, using this iodine as kind of the connector between the two formulas, I'm now able to jump onto this second formula, and I'm going to use the ratio between iodine here and the hypochlorite ion. So now I can start to find out more information about this. So this is a 1:1 ratio. So that means that we also have 0.000805 moles of the hypochlorite. And again, this is in the titration flask. So we pipetted 25 mils of this bleach solution. So that's why I have it here as in, that's how much hypochlorite there is in 25 centimeters cubed. But this part of the question, E part I, wants the answer in moles per litre. So again, you could use your molarity formula here. I've just done it in the way that I do it sometimes, where I'll just write, this is how many moles I have in 25. I want it in moles per litre. So I find out, what do I have to multiply by? And I have to multiply by 40 to get it in moles per litre. So this is the answer to E part I, and that is the concentration of the diluted bleach. Part 2 of that question, you have to work out the concentration of the original bleach. At the beginning of the question, we're told that the student pipetted, or maybe just measured out, 25 mils of bleach and diluted it up to a 500 centimeter cubed volumetric flask. So that gives us a dilution factor of 20. So to work out the concentration of the original bleach, it is the concentration of the dilute bleach multiplied by the dilution factor, and that gives us 0.644 moles per litre, and that's the answer to E part 2. Jumping over to part F then. Part F wants us to represent the concentration in grams per litre. So I have the moles per litre. As I just said, that's the answer to E part 2. So that's moles per litre. I now want to get it in grams per litre. So to go from moles to grams, I'm going to use my mass triangle, which, remember, you need to learn this formula and the molarity formula off by heart for the exam. So I've worked out the MR of the NaClO. The reason I'm working out the MR of this is because this is written in bold in F part 1 of the question. So whatever is written in bold in that part of the question is what you're working out the MR of. So in this case, it's the NaClO, and I worked that out to be 74.5. And then to get the mass, I'm just doing the 0.644 multiplied by the MR, and that gives me as 47.98 grams per litre. That's the answer to F part 1. And then last part of the question is to change that from grams per litre into percentage weight per volume. So just remember that what this actually represents is percent, means that we want it per 100. The weight is the grams, so we already have it in grams. And we now just want to have it in grams per 100 centimetres cubed. So again, I've just written out that I have 47.98 grams in 1,000 centimetres cubed. That's just taken my answer from up here. And to get it in per 100 centimetres cubed, I'm just going to divide by 10. And that is the answer for F part 2, percentage weight per volume.